Hi all, Frixie Dev here. In the previous video, I've covered how to create a transaction system for our upcoming cryptocurrency. It is required for you to check out my previous videos if you haven't watched them, because they are going to play an essential role in this video. I've put links to them in the description. So today, we'll build the core component of our cryptocurrency, the distributed peer-to-peer network. It is not only required for a blockchain to work, but also after building it, people can really use our own blockchain network publicly as a cryptocurrency like other basic proof of work cryptos on the market. So, what is a P2P network? First, we have to understand what is a client-server model first. So in our life, pretty much everything we use currently follows the client-server model. The network works by having a server, and every machine will connect to that server. You can send requests to the server, and the server can send back responses. Think of the system as a company, and the boss is the server. The boss is the one who makes decisions and controls every action of the application. But in a distributed peer-to-peer model, machines, called nodes, can send messages to each other without having any third-party system involved. Think of it as a group of friends working together. People can work independently, and decisions will be made by the majority. In a cryptocurrency network, people should be able to at least send transactions and suggest new blocks. Now, without further ado, let's code. Now, what we are trying to achieve. We will need a network where nodes can connect with and send messages to each other in a peer-to-peer fashion. After that, we will add functionalities like broadcasting transactions and suggesting new blocks, sending chains, and change information. I'll be using WebSocket, a TCP-based protocol. Please learn about it to have a better understanding with what I will be doing. Okay, so now we will install WS through npm. Alright, so let's understand the basic concepts of WS. So we can create this, we can import the package like this. We'll create a server like this. You can choose any port you like. You can listen to connections. Basically, we will create an event handler, and every time a node connects to us, the event handler will be triggered. We can also get the socket from an address like this. So an address should have a form like this. So here's the IP address plus some port, just like that. Oh wait, to create a server, you should use the new keyword because it's a constructor. So you can also open connection like this, and you can have an event handler after that. You can also handle the close event, which is technically just means that the other node has disconnected, and we should have an event handler for that. Next, we can also listen to messages. Just like this. Okay, so now let's create a basic node. Okay, so we'll get the old data first, and you should be able to export all the function, the classes we have created in the previous videos. Alright, so let's import it here. Now we would also like to have a static mint address. So I've already prepared a file here which contains the key we will be using in this video. So here we'll create a private address. Also, if you haven't known how to generate key pairs, be sure to check out my last video for that. So here we can generate the key pair from the private key. And the public key. And you should also be able to create your own key pair. Actually, I'm just gonna assign it directly. And generate the key pair just like the last one. Now let's add some real new code. So I'm just gonna require the package, assign the port to 3000. I'm just gonna have a list of peers. It's gonna be empty for now. And our address. I'm using localhost because it's easier to test that way. I will also log out that our node is listening. And I'll create an event, an error handler right here. And we will log out the error if there are any. Alright, and because the minting address is static and should never be changed, we will now also change the genesis block and the old key too, actually. Yeah, just like that. Alright, so now let's handle some message. So a message should have a form like this. It should have a type to something, and it should have data. Actually, I'm just gonna do lowercase here. Alright, so the first message we would need to handle is called handshake. So handshake is the process where you send address to others to say that, hey, please connect to this address. So the first thing we would do is we would connect to an address, send him or her our address, and they should be able to send, no, they should be able to connect back. Alright, so it should have a form like this. And the data. should be a list. Some address, some address, some address. Alright, so I'll create a function called produce message just for convenience here. Now let's implement the main system. Alright, so first we will need to have the connection listener. And we should be able to listen to its message. So because the message sent is in the form of JSON, we want to process it as an object. So I'm just going to parse it out. Here I will create a switch case to handle all sorts of message. But for the first one, we'll just handle the handshake. And then we'll just connect. And now we'll implement the connect function. Pass in an address and we'll connect to that address. So first we will need to get the socket of that address. After that, we'll open the connection and send them the handshake. So we're just gonna turn it to JSON. Pass in our address here. But to actually do stuff in the future, we'll need to a list that holds all the sockets and the addresses. So I'm just gonna create 2 arrays here. Actually, you just need 1 array, but I will create 2. One for holding both address and sockets. One for address only. Alright, so we wouldn't want to connect to our own address or an address that we have already connected. So let's cut this and place in a if statement. We'll just paste it in. And now we should be able to send them our connected address as well using the spread operator. We would also like to inform the nodes we have connected that we are connecting to a new node, so that they would know too. Alright, and now we'll be able to push the address to open and connected. So I'm just gonna create 2 if statements to check if it's already exists in the list. And now let's create an event handler if they disconnected. Oh wait, we have to move to the if statements here. So we want to remove them from two of our arrays if they disconnect. Alright, so to connect to all prefix peers, you can add this line in. Alright, now let's start integrating our blockchain into the network. Now that we have our network running, let's start diving into the real deal part of the article, the cryptocurrency. To create a cryptocurrency, we would need to be able to broadcast transactions, suggest newly mined blocks. New nodes should be able to ask other nodes for their chains too. But first, we'll add necessary stuff that have been missing in the last videos. So first of all, you can see that because when we send messages, we're effectively passing objects to JSON, meaning that the methods of an object, in this case, they are transactions, blocks, blockchains, will disappear. We can solve this problem by making our methods static, so we can reuse them without having to touch the real objects themselves. And in the previous video, the validation method of blocks and transactions are not really ideal, so I will update them while we are turning everything static. So first, we need to change this static, and I would like to inform you guys that this code is the code from GitHub, which is the updated code. So please check out the code from the previous video. I've left a link in the description. So we will remove all this keyword and use block instead. Seems fine. Oh, actually no. Is valid from transaction will be turned to static too. Alright, seems pretty fine. So now let's move over to is valid from the blockchain. Simply makes it static, and now that we have a new method, we must do this. And technically, we will be changing get hash to static also. So yeah, let's do this. Alright, now let's move to is valid from transaction. Right, just that there are not much to ask for. Okay, so now it's the get hash. Changing all this to simply being a block. And now we will update the related methods. So first, the hash should be block.getHash this, right? So the next one is mine. All right. And add block. And add transaction 2. Alright, so now let's actually handle some message. The first message we will handle is the transactions. So before we do that, I will create a handy dandy send message function to send message to all nodes. And in the meantime, why don't we stringify it? Alright, so a message for transactions should look like this. The data. This data will effectively be the transaction object which has been turned into JSON. The transaction object. Okay, so it's just gonna look like this. So let's remove this, get back to our message handler. Let's create message type, create transaction. So we're just gonna get the data and add it to our transaction pool. Okay, and you can now send a transaction like this. So the transaction object goes here. And we're not only just sending, we also need to add the transaction to our pool. Right, it's just gonna look like this. I'm just gonna remove it now. Okay. So let's move over to the hardest part. It is mining and sending new blocks. So a message for suggesting new block should look like this. I call it replace chain, but we are not actually replacing the whole chain. We're just adding a new block. So we just send the new block and the new difficulty. Now, how would we handle this message? The simplest thing we would do first is to check if the block is valid or not. Then we will add it to the chain and update the difficulty. The block is valid when it has valid transactions, which means that the transactions are in our transaction pool. The transactions are valid according to our old methods. It has a valid hash, which means that it matches with the block's information, which is also called the block header. It has a valid difficulty, which means that it can't be greater or less than our old difficulty plus or minus 1. It has a valid timestamp, which must not be greater than the time they sent us, and can't be less than the previous block timestamp. This is not actually a fulfilled way to adjust difficulty, but at least it shouldn't create too much damage. Alright, let's remove this message. Start implementing. just gonna get a new block and a new difficulty here. And I'll create a clone of our pool called RTX, and we'll have all the transaction to be converted to JSON, because I mean turned into a string, because we are we will use it to compare. And here I have the RTX, which is basically the transactions in the block, but without the minting transaction. Actually, let me see. Oh, it's actually public address, not public key. Alright, so we will perform a map again. Right, and we will assign n to the original length. So what we're effectively doing first is to check if the previous hash matches with our newest block previous hash or not. Because why? Because that would mean that they are sending us a duplicated block. And now we'll actually do stuff to our RTX and the RTX. We basically want to check if transactions from the block exist in the transaction pool or not. So I'm just gonna implement a basic algorithm. It might not be performant, but it works for now. So I'm just gonna loop over the RTX. No, actually, I'm not gonna loop over the RTX. I'm just gonna loop until it hits the length. It kind of loops over the RTX, but not really. So I'm just gonna get the index of that. So we have the transaction from the RTX, and we check the index, its index in RTX. If it's equals to -1, that means that it doesn't exist in the transaction pool, so we can just break it and see that this is definitely a faulty block. Or else we're just gonna slice it out of RTX. Same with the RTX too. Alright, so now let's perform some checking to see if this block is valid or not. So the first thing we will do is check if the transactions are valid, if the transactions exist in the pool or not. So if it exists in the pool, the RTX should be empty by now, because we are effectively removing every element from the RTX. So here, that's the first condition. The next condition is to check if the hash is valid or not. Now, we'll check if the hash matches with the difficulty. And we will just check if it has valid transactions or not. And of course, we can't forget the timestamp. Note that because the Genesis block has an empty timestamp, so we just skip over the over this condition if the timestamp is empty. And we will check if the hash of the latest block is equals to the new block's pref hash or not. And then finally, we'll check the difficulty. Oh, wait a minute. We haven't finished with the timestamp. There's still this one. Alright. 8. No. Cool. So now let's check the difficulty. Now, if all conditions are passed, we're just gonna push the block into the chain. We'll update the difficulty as well. And our transaction pool should be RTX now, because we have effectively removed all the mined transactions, which is going to parse it back to object. And let's just break this case. Alright, but turns out there's one really dangerous problem. If one miner mines a block, he wouldn't really know if his block came first or the other one sent to him came first. Yes, this does happen due to many impacts. One of them is internet problem. Imagine if someone mines a block before you and they have sent to other nodes, but they sent to you when you have already mined your block, which is not really correct, and you will be left behind by other nodes. So yeah, there are many approaches to this, but I have coined out a really simple system which leverage the use of majority support. We can effectively implement this functionality using a boolean variable called checking and use the function setTimeout. Basically, the idea is that if the block's pref hash is equal to the latest block pref hash, then it's probably a block that needs checking for replacement. We'll set checking to true to indicate that we are checking. Then we'll request other nodes for their latest block. We'll wait for a period of time, which I will set to 5 seconds using setTimeout. Then we will set checking to false, canceling the process, and the block that appeared the most is likely the block we need. I will also implement a system to skip on all similar blocks after we have had the correct answer. And we are not just sending the block, we will be sending the new transaction pool and the new difficulty. So now let's create new variables first. Alright, so now let's add an else. Wait, let me recheck first. Yeah, that's correct. Okay. So what we are doing here is that basically before we check this, we need to know what we'll checked have, right? So basically after we check this case, we will push the JSON to it. All right. So we are pushing the previous hash and the timestamp of the previous block. Why would we need to do this? Well, basically, the case is technically it's just technically the pref hash, and if somehow a hash that's the same as this appeared again, I'm just gonna push in a timestamp to be sure. So now its condition should be like this: includes gonna effectively copy the whole thing here. Alright. And now we will get the position of the block we need. We'll set checking to be true. We'll send others requesting, send a message to others requesting checking. So request check, we just have a form like this. You're just basically sending your address so that they could send back. And oh wait, my bad. Yeah, it should be like this. Now we'll create a set timeout, create a function here. We'll call this function after 5 seconds. So after 5 seconds, we just set checking to be false, and we will find the most appeared block. So the default should be the first block, and then we're just gonna loop over all the group. And just like I have said, we are not only just sending a block, we'll send a group of block, difficulty, and pending transactions. Right, so and all these groups should have a form of a string. So yeah, now we will just check the quantity of the group to see if it's smaller than the current block we are checking or not. If it is, then we will just set the new most appeared to that group. Alrighty, now we should have our group parsed into a normal object. And I haven't said about this, but it will have a form of an object. No, it will have a form of an array containing the block and then the transactions and the new difficulty. We'll just copy the array. Here is our new difficulty. And after that, we're just gonna remove all the blocks from the check array. Note that this one is more of a proof of concept. We often would like to check if the block is valid or not, just to be safer. But this should do our job for now. So now let's create a way to handle the request check. right here. Now, because we have sent our address, they're just gonna find the address in open, and then they find the socket, and they will send a message to us. So we'll send new message here. And we'll call this type send check, indicating that we are sending back our checks. Here we'll have the last block, the transaction pool, and the difficulty. Alright, and of course we need to put a break here. Now let's create a way to handle the send check message. So we will only add it to check if we are checking, which means checking is enabled. Alrighty, so the handler is finally done, and you can mine blocks like this. Just gonna put some new lines here so you can easily see. Transaction length 0. And we will produce that message right here, effectively sending the newly add block and the new difficulty. Alright, so you can now mine transaction like this. Okay, so that should do the job first, but there's one new really small problem. For new nodes that have just joined the network, there are two ways to get the latest chain. You can either get a chain from a trustworthy source, or you can ask the chain in the network. Note the size of message is limited, so we won't be able to send the whole chain, but we would rather send blocks one by one, and we'll also send the information. So now we can implement the second solution like this. First, we'll create a variable called temp chain, which is basically a new chain. So basically the idea is that all the blocks sent will be added to temp chain, and if temp chain is valid, then we will transfer all the data from temp chain to our main J chain. Alright, so now we should have 4 message handler, 2 for requesting and sending back blocks, and 2 for sending difficulty and transaction pools. And yeah, okay. Now we will do the chain first. Okay, so we will handle the request first, because yeah, so we just gotta get the socket first. And note that when you request chain, it's just like request check. You are sending your address. So now we should be able to send back a message with the type of type send chain. And the data should look like this. And what we are doing is we are sending blocks one by one, right? So I will implement a system that sends the block continuously, and then we should be able to create a finish property, which basically holds the information of if is we are how do I say this, to say to the other guy that we haven't finished sending, or we have finished sending. So if we have hit the last one in the chain, which is it will be false, it will be true, or else it would be false. Okay, so now we will have a handler for that. Block, finish. So if it's finished, if it's not finished, we will continue to push it into tab chain. Or else we'll just check if tab chain is valid or not. And then if it's valid, we will assign its chain into J chain. Then we will empty the J chain. Alright. Now we should be able to create two other message handler, which is called type request info and type send info. So like I've said, we're just gonna request other people for the difficulty and the transaction pool, and then they're gonna send us back just that. Request info. We're just gonna, of course, find the socket. We're gonna send back a send info message. Now let's handle this message just like this. Really simple. Oh yeah, it's supposed to be send info. Alright, and I forgot to break all the cases. Here, here, and here. Alright, so, but note that you can send requests from a trustworthy node, or just based on the majority. You can just send the request to all the nodes in the network. And wait a minute, I forgot that when I removed the holder key pair, I forgot to paste in the new public address. Alright, okay. So now let's test our chain both in localhost and public. So first I will test in localhost. To test, I will start two new consoles with different port, my address, and public key. So for the first one, I will set our PS to be empty, which is just technically this one right here, and the port is 3000. Here's the address. Perfect. So now I'm gonna paste it here, call it jcoin2, and give it a different address and port. So I'm just gonna say 3001, and this one should be able to connect to the original one, which is localhost at port 3000. And I will set this one. I will create a transaction in this node, and I will create a mining functionality in this node. So this node will create a transaction and this node will mine, and after a period amount of time we'll print out the chain. Alright, so first of all, and I'm gonna use set timeout because we can not really accurately create transactions at the same time, right? New transaction, address 2. Oh wait, I haven't set the private key of the other node. Wait for me here. Alright, and we are going to send it to the public key of this one, which is technically his address, which is right here. Alright, very nice. We'll send 210 as a gas fee. We'll sign the transaction just like usual, key pair, and then we'll send message saying that, hey, I have a transaction, please mine it. Alright, here's the transaction. We're gonna add the transaction to our pool. We are going to do this after 5 seconds, and after I would say 10 seconds we'll print out the chain, and I'll also print out open, just for you to know that we have connected, like two of these nodes have connected to each other. And here I'm just gonna pass in the time, which is 10 seconds. Right, so in this node I will mine the transaction. So right here, if the transaction pool is not empty, we will start mining. Pass in the public key and produce the message here. Right, sending the last block and the new difficulty, and we're gonna execute this after 6.5 seconds. Alright, seems good. Alright, so let's test our chain. Oh, actually, Oh yeah, I've just remembered that. Okay, so this, oh, so I've changed it to address, so this should be to key, and it should be empty. I used to have this error before, so yeah, I remember it now. It should be like this. Yeah, it should be like this. Now we're just gonna start R2 of the chain. Now let's wait for 10 seconds. Alright, so it worked. Voila! So we have just created our chain. So now I will have my friends to help me test the public chain. So now let's just close this. Since we have successfully created the thing. After some port forwarding, I have here my chain, and here is my friend chains. As you can see, it works fine. My node is the bootstrap node, which sends the transaction, and my friend's node is the nodes that should be mining. So as you can see here, the chain is printed out perfectly. But note that this network is not meant to be production ready, but this network should be fine for now. So yeah, for now we have completed the core component of our cryptocurrency, the distributed peer-to-peer network. Now people can really use our own blockchain network publicly as a cryptocurrency. The code used in this video has been put in the description below. And also, you can check out the article version of this video on dev.to. Great thanks to my fellow friend Apple, who has contributed a lot to this project. And to those who are watching this video, I love you guys a lot. You guys are definitely my motivation to finish this series. If you want me to keep making videos about blockchain development, please comment below what you want me to do. And yeah, please subscribe to get notifications of my upcoming videos. Best regard, Frixie Dev. Peace.